Let's talk about these problems that have the parallel plates in them, okay? So let's imagine that we've got these two plates here, okay? And we've attached a battery to these, right? So maybe the top plate is positive, the bottom plate maybe is negative, okay? Now, what this does, if this side's the positive side, that's the negative side, it makes the top of this positive by basically it's pumping electrons this way, right? Right, and it makes the bottom plate negative, okay? This, by the way, creates actually a downward electric field, right? A positive charge in this space would actually be propelled downward, okay? Now let's imagine we have a charged object in there and it's being suspended, right? It hovers there in the midair. That's what we're talking about, right? It just sits there. Doesn't move up, doesn't move down, doesn't accelerate any direction. It's suspended, right? The charge on this, of course, would have to be negative, right? A negative charge would be attracted to this positive, repelled by this negative, and in fact, there'd be an upward force, right? And that upward force is the electric force, and that force is EQ, okay? And that comes from the formula E is F over Q, right? Now, the force down acting on this thing, of course, is the force of gravity, right? And if it's suspended, these forces are equal. This is like a famous problem. That's why we put it on the test, right? You're going to see a lot of these. You'll see them on IB tests, right? So the concept is that these guys are equal, right? The force of gravity, right, mg down equals the EQ that's up. EQ is always up, right? The force of gravity is always down because gravity defines down, right? Gravity can't be any other way but down, okay? So we've got this thing suspended like this. And then the other thing you've got to know is that this thing has a potential. And it's a bit like sort of like the height of a hill, okay? And the electric field is like the slope of the hill. So this maybe say it has a potential of 200 volts, okay? The electric field in there is how much potential it changes divided by the distance. It's a bit like the slope. This is the rise, this is the run, okay? So the electric field is like this, the slope of potential, okay? So if this is our distance here, we've got this, right? So basically, you can substitute E is equal to V over D in there. So we sort of have these three equations, right? mg equals EQ. If they tell you the V and the D, you can find E and substitute it in there, right? Sometimes you find this, you find E and you go this way, and you solve for the D or the V, okay? So it's sort of like one of those things, okay? Now, let's just look at the charge distribution here. We've already said that if you have positive plate on the top, negative plate on the bottom, a negative charge between the plates would feel an upward force. If you reverse that, let's reverse that. Let's put the negative plate on the top and the positive plate on the bottom. Now the question is, what kind of charge would feel an upward force? And of course the answer is that it would have to be a positive charge, right? Because the positive charge would be attracted to these negatives and repelled by these positives, right? So that's going to feel an upward force. In this situation, a negative charge would feel an upward force. And that's how you answer those questions: which plate is positive, which plate is negative, okay? Or you might have to answer, what is the charge if you're solving for the charge?